6.1, Introduction to Polynomials. Well, we're starting a brand new unit here, and this one's on the polynomial functions. Well, let's talk. We've kind of worked with polynomial functions. We haven't really talked about what they are. Polynomial functions are anything where we can write it as, like right here in this middle of the screen, f of x equals some number times x to a power plus another number times x to the next power that's smaller than that, all the way down till you get to a constant at the end. Like when we do x squared x and no x, those kind of problems. The main catch for the polynomial functions is the variable has to be a whole number. It can't be a fraction that they can't reduce. It can't have a negative exponent, and it can't have a variable up in the exponent, and because that would put a variable in the denominator, and we can't have a variable in the denominator, and there can't be anything that has a power with a root, with a square root or a cube root or any kind of root with a power, because that's not a whole number power. Those are actually fractional powers. So when we look at number one, when it says which ones are not polynomial functions in state y, well, this first one is not a polynomial function because that is that's a root. We can't have a variable raised to a root power or a square root. A square root is a 1/2 power. So this one's a 1/2 power or a square root. The next one, 1x to the fourth plus 5x to the third plus 2x, yes, that is a polynomial function because everything has whole number powers and it's written in order even. Well, the next one is not, because this has a variable in the denominator. So variable in denominator. I should have put in bottom, it's shorter to write. Denominator. So that one's not a polynomial function. Well, next one has a constant raised to a power. So it is an exponential function. So that is not, because it has a variable in the exponent. You can't have a variable up in the power. So that is not a polynomial function. And then the last one, 5x to the third minus 2x squared plus 8, that is a polynomial function. All the powers are whole numbers, so yes. Okay, well, let's talk about some key parts of a polynomial function. When you have separate terms that aren't being multiplied together, the rules change when they're being multiplied together. When they're separate terms like this, the degree is the highest power we see on the variable. So this is an x cubed, so the degree is the highest power on a variable. Highest power on a variable. So variable, that's an I. So on this problem, it would be a degree of 3. The leading coefficient is the coefficient with that highest degree term. So on this problem, it's a -2 because that's the number in front. So it is the coefficient of highest degreed term, of highest degreed variable. That's variable if you can't read my handwriting. Okay, the leading term is the whole term that has the leading coefficient. So on this one, it's -2x cubed. So it's the term with highest degreed variable. Highest degreed variable. And then the next term we're going to talk about is the constant term. And in this problem, that's 8. It is the term without any variables. I'm just going to put no variables. No letters. On the one that's a number by itself. So, okay. I don't know why I circled that. Anyway, let's move on to number 2. I'm going to erase that circle because it didn't need to be circled. Okay, so on number 2, standard form is where you're going to put it in what's called descending order of the variables. You start with the highest power and you work your way down. So this would be f of x equals, the highest power looks like x to the fourth. So 1x to the fourth or just x to the fourth. And then we've got a 3x to the third. I'm marking out so I can see what I've used. And then a -15x squared. And then minus 2x. So for this one, is it a polynomial? Yes, all those powers are whole number powers. The degree is the highest variable power exponent we see, which is, this one's a degree of 4. The leading coefficient is the number in front of that term, which is a 1. The whole leading term is that whole term, which is just 1x to the fourth or x to the fourth. The constant term, this one has no constant term, so it's 0. You might be able to put none, but it's 0 at the number at the end. There's no constant, no number that doesn't have a variable with it. So let's move on to number 3. If I put this one in standard form, the highest power is 8x to the third. The next highest power is x to the first, which is just x, and then we have minus 9. So the degree is that highest power, 3. Yes, it was a polynomial function because this is, when there's not a power, that's an x to the 1. Those are all whole number powers. So yes, we have 8x to the third, x to the first, and 9. The leading coefficient is this coefficient, which is 8. The leading term is that whole term, which is 8x to the third. The constant term is a negative 9. It's the number without a variable. Okay. Last one of these. Let's put this in order. I see a 1/2. So let's see. F of x equals, the highest powered is 1/2 x to the 6th. And then I see a 2x cubed. And then I see a negative 9x and a minus 8. Negative 9x minus. Okay. Is it a polynomial? Yes, all the powers are whole number powers for the variables. 6, 3, 1, and 0. This is an x to the 0 here. So the degree is the highest power we see there when we're not multiplying anything together on the variables. The leading coefficient is the number in front of that term, which is 1/2. The whole term was 1/2 x to the 6th, and the constant term was negative 8. And we are through with the front side of the notes. Well, number 5 is just adding like terms. So I didn't even spend much time on this one, so I didn't do very many examples. I did one example of adding. So we're going to add like terms. So the highest powered 3x squared. So 3x squared plus 1x squared would be 4x squared. So this is equal to 4x squared. I've used that term and that term. There's nothing outside those parentheses, so we don't even need those parentheses. Since I did the x squareds first, now I'm going to do the x terms next. And I see a positive 11 plus a negative 5. 11 plus negative 5 is positive 6x. So I've used those two terms. And now I have 4 minus 13. Positive 4 minus 13 is negative 9. And there is our function when we combine like terms. Okay. Next, we are going to subtract functions. And when we're subtracting, my advice, my recommendation to you, there's nothing outside the first parentheses, but there is a negative outside of this one. So that's going to affect that term, that term, that term, and that term. So distribute the negative. So that's going to be negative 1, negative 2y squared, positive 5y, positive y cubed. Now we can add like terms together. And if I start with the highest agreed power, the highest power I see on a variable is y to the third, and there's no other terms to combine to that one. So this is going to be equal to a positive y to the third. I've used that term only so far. And now I go to the y to the power of 2, the y squared problems, and I see, or terms, I see a 4y squared and negative 2y squared. If you add those together, you get positive 2y squared. So I've used that term, and oops, I have not used that term. I've used that term and that term. Now let's go to the y terms. And I see a positive 5y and a positive 1y, which would be a positive 6y. So I've used that term and that term. And the very last two constants, I see a negative 3 and a negative 1 would be a negative 4. And that is everything we need for that problem. So we are through with number 6. On number 7, never, ever, 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 ever distribute a power when there's a plus or a minus in the middle. You cannot, and I repeat, do not write, that's not equals, do not write 4x squared plus 25. That is incorrect. That is horrible math. It is a common mistake. They love on standardized tests to see if you'll fall for that trick. When you're doing one like number 7, let me clear this off real fast. When you see a quantity squared, a binomial squared, write that binomial twice. So that is 2x plus 5 times 2x plus 5. And then you are going to either box or FOIL. If you have to use a box, you go right ahead. But Algebra 2 on, normally it's faster and it becomes more intuitive to skip the box and just go straight to foiling. But to refresh your memory, if you're a box person, you would make a box. Since this was 2 terms by 2 terms, make a 2 by 2 box. We put 1 outside the first term, 2x outside the first box, positive 5, 2x, positive 5 again. And then we multiply whatever's outside the boxes and write those down. So 2x times 2x would be a 4x squared. 2x times 5 would be a positive 10x. I'm going to put the plus sign. And on this box, we have a 2x across the top and a 5 down the side. That's 2x times 5. That's another positive 10x. And the last box is 5 times 5 is 25. Then to get the final answer, we combine any like terms and write it in order of highest power to first. But before we write the answer, I'm going to FOIL this. FOILing is where you multiply the first two terms together. The first two terms, and you get 2x times 2x is 4x squared. It was the same as this box here. And then we had a 2x times 5. And a 2x times 5 is the same as this box here, which is with 10x. That was the outside two terms. Then we take the inside two terms, which, I don't know, those two may be backwards. They're both. It's another 5 times 2x is another 10x. And then finally, we take the last two terms, which is 5 times 5, which is positive 25. So foiling is just a visual, or just a inline version of the box. The box is more visual, but now we combine like terms, and you get 4x squared equals 4x squared plus 20x. I forgot my x when I wrote that down, plus 25. And that is what you get when you multiply that out. If you had just squared the power, if you just distributed the powers, you lose the whole middle term, which is incorrect. Now, for standardized testing, there's actually a faster way to FOIL. What we just did, when you have a plus b squared, it's always going to be the first term squared first, the last term squared last. So a squared and b squared is what those were supposed to say. The middle two terms are these two terms multiplied together and doubled. So 2 times a times b. 2 times a times b. So double a times b, which is what we had here. 2x times 5 is 10x, and we double that, you get 20x. So if you want to gain some speed on a standardized test, learn how to FOIL fast. But you don't have to. You can always go back and write it out long ways. If you need to use the box, you go right ahead. Number 8 is the same process that we would call FOIL, but this time we have 3 terms by 3 terms, so it's a 3 by 3 box if you're going to do box. And if you want to do box, you go right ahead. I'm going to do this without a box, and so it's just triple distributing here. First, I have to take this x squared and distribute it to every single term. So that is going to be x squared times negative x squared is negative x to the fourth. X squared times negative 9x is negative 9x to the third. And then x squared times negative 4 is negative 4x squared. Now I'm going to distribute this next term, 6x, to all 3 terms. So 6x times negative x squared is negative 6x to the third, because x squared times x is x cubed. 6x times negative 9x is negative 54x squared. And then 6x times negative 4 is negative 24x. And finally, I'm going to take the negative 7 to all 3 terms. Negative 7 times negative x squared is positive 7x squared. Negative 7 times negative 9x is positive 63x. And negative 7 times negative 4 is positive 28. And no x at all. And now we look for like terms. So I'm going to start with the x to the fourth power term first. There's only one of those, so my answer is going to have a negative x to the fourth. I'm going to mark it out so I don't get confused. And now I go for my x cubed terms. And here was an x cubed, and here's an x cubed. I can't read, that's a squared. Okay, so that looks like negative 15x cubed when I combine like terms. I want to make sure there were no other x cubes. So we should have had there should have been negative 6x cubed. Okay, that was. Now I'm going to go to x squareds. And I see a negative 4, and negative 54, that's negative 58. Negative 50, no, that's not an x squared. Negative 58 and 7 is negative 51x squared. And I've used that term, and that term. So now we're down to the x's. And I see a negative 24x and a positive 63x. And that would be negative 24 and 63 is negative or positive 39, I believe. I'm going to double check myself. Okay, I agreed with 39x. And then, so I've used my x terms. The only thing left is the constant, and there was only one of those, and that was a positive 28. And I believe we are done with that one. So let me double check my answer. Negative x to the fourth minus 15x cubed minus 51x squared plus 39x plus 28. We are done with number 8. On number 9, okay, I'm going to clear my scratch work off just so it looks a little less. We can do the box, which this one's a 2 term by 3 terms, so you could do a 2 by 3 box, which would work perfectly fine. But like I said, by algebra, so that'd be x and negative 7, and here would be x squared plus 2x plus 1, and then you'd multiply all those out. Or we distribute x to all three terms, which is what I'm going to do. So that would be x times x squared is x cubed, x times 2x is a positive 2x squared, x times 1 is a positive 1x, or just x. Now I'm going to distribute the negative 7. Negative 7 times x squared is negative 7x squared. Negative 7 times 2x is negative 14x. And negative 7 times 1 is negative 7. And now, I'm not even going to switch colors. We start with our final answer. It's going to be the highest power at first. It will be x cubed. And then I have a 2 minus 7 is negative 5x squared. And then we have 1 minus 14 is negative 13x. That's an x squared. And then we have minus 7. And I'm going to double check myself. We have, this is number 9. We have x to the third minus 5x squared minus 13x minus 7 is correct. And we are through with number 9. For number 10, once again, I see a binomial squared, so that means we have to FOIL. So I would start with that one because that would, order of operations, we do exponents first. So we have to multiply 2x plus 1 times 2x plus 1. Well, if you remember, there's a fast way to do that. It's going to be, now there's still a 9x minus 4 at the end, so I'm going to put this in a parentheses. So 2x times 2x is 4x squared. Then the middle term is 2x times 1 times 2, which is 2x times 2 is 4x. It's going to be a 2x plus another 2x, which gives you 4x. And then 1 times 1 is 1. So that is the fast way of foiling that. If you need to, go back and that's 2x squared plus 2x plus 2x plus 1, which is what I just got. And I still have the 9x minus 4 here. So, okay, this is equivalent, so it's equal. Now, I'm going to do the same thing I did on the previous problem. I'm going to take 9x, I was like doing the 2 term, but it's the same process of doing the, you're going to distribute. It doesn't matter whether you take this to both of these, and this to both of these, and this to both of these, or if you take this to all 3 of those, and that one to all 3 of those, you'll get the same answer. So 9x times 4x cubed is 36, x cubed. 9x times 4x squared gives you 36x cubed. 9x times 4x is 36x squared. Gotta read in the right, less sloppy. 9x times 1 is a positive 9x. And now I'm going to do negative 4. Negative 4 times 4x squared is negative 16x squared. Negative 4 times 4x is negative 16x. And negative 4 times 1 is negative 4. And now I look for like terms. There's no other x cubed, so we have a 36x cubed. So I've used that one. I see a 36 minus 16, which is a positive 20x squared. And then I see 9 minus 16 is negative 7x. And the only other term left is the constant of negative 4. And I'm going to check my answer. I see number 10 says we have 36x cubed plus 20x squared minus 7x minus 4 is correct. So let's move on to number 11, which is another 3 term by 3 terms. So it is similar to what we did on number 8. The catch that I would do first on number 11 is just to make, you can go any order, but I'm going to recommend rewriting that. That's x squared minus 5x minus 13. You'll still get to the same answer if you don't do that, but just to make it, sometimes it's a little prettier just to do that in order. So now I'm going to have 3x squared times x squared is 3x to the 4th. 3x squared times negative 5x is negative 15x to the 3rd. And then 3x times negative 13 is negative 39x squared. So it's 3x squared times 30, negative 13. Now, I'm going to switch colors. I'm going to do 11x times negative 5x would be negative 55x squared. 11x times x squared is positive 11x cubed. And 11x times negative 13 is negative 143x. And for my last 3 terms, I got to do 4 times negative 5x, which is negative 20x. 4 times x squared is a positive 4x squared. And then 4 times negative 13 is negative 52. And so now let's put these in order. And I see only one x to the 4th term, so 3x to the 4th. I always like to mark them out just to make my life less confusing. You don't have to. Negative 15x cubed and 11x cubed is negative 4x cubed. I don't see any other x cubed, so those are done. Oops, I did it again. Marked out the wrong one. Now I'm going to do my x squared. So I've got negative 39x squared and negative 55 is negative 94. And negative 94 plus positive 4 is negative 90x squared. So I've used that one, and that one. And my x terms, I see negative 143 and negative 20 is negative 163x. And then minus 52. And now let me check my answer to make sure I didn't make a mistake. 3x to the fourth minus 4x cubed minus 90x squared minus 163x minus 52. I agree with that. Okay, but I borrowed space, so let's do the last one. So I'm going to clear the, oh, I'll just erase this section right here. I don't get to my box clear. Okay, for this one, my advice, that negative 3 is going to get multiplied in somewhere. You don't multiply it into more than one parentheses. You pick one and multiply it in. I'm going to wait till the very end. So I'm going to start with these two terms first. So I'm going to leave a negative 3 out front, and I'm going to leave that x plus 8 at the end, but I'm going to multiply x times x is x squared. I'm going to FOIL this one. X times negative 2 is negative 2x, plus a positive 5x. 5 minus 2 is a positive 3x when I combine those like terms. And then we have minus 10. If you need to write that out, that was x times x was x squared. We had a minus 2x, a plus 5x, and then a minus 10 for those two. And so that became a positive 3x in the middle. I just went ahead and combined like terms. Now, I'm going to distribute this x plus 8 to all to those. So that makes this, the negative 3 stays out. Oh, these are all equals. Negative 3 stays out front. So x times x squared is x cubed. X times 3x is a positive 3x squared. X times negative 10 is a negative 10x. Now I'm going to do the 8. 8 times x squared is a positive 8x squared. 8 times 3 is a positive 24x. And 8 times negative 10 is a negative 80. And I'm going to combine like terms, and then we'll distribute the 3. So let's see. If I leave that negative 3 out here one more step, I see an x cubed. There's not any more of those. I see a 3x squared, and an 8x squared is an 11x squared. So I've used that one, and that one. I see 10x and 24x is a positive 34x. No, that was a negative 10 and plot. So let me undo that. Negative 10 plus 24 is positive 14x. Good thing I called all that sign. And then minus 80. So now distribute negative 3 and we're done. So this will be negative 3x to the third minus 33x squared minus 42x plus 240. And I'm going to double check before I hit done on this video. We have negative 3x cubed minus 33x squared minus 42x plus 240. That is everything you need to do this assignment. The only other thing that did pop up on the assignment is making sure you know the terms monomial, binomial, and trinomial. Well, I've mentioned some of those terms already. And the root word is the key word there. Monomial has a root word of 1. So monomial is a one term only. Binomial is what we just dealt with on some of these. Binomial had 2 terms because the root was bi, which was 2. And trinomial had a root word of 3. So trinomial was a 3 term. All of them are polynomials, but these are special types. Monomial had 1 term, binomial had 2, trinomial had 3. And then that right there is everything you need for this assignment. Good luck to you.